Alright guys, in this video we'd like to try to find a Taylor series or Taylor-Maclaurin series representation for cosine of x. We want to find the Maclaurin series. Alright, remember that the Maclaurin series of any function is equal to the power series, so t of x is equal to the sum, and from 0 to infinity of, well, any power series is always equal to some coefficients times x minus x naught to the power n, right? But the Maclaurin series, what makes it a Maclaurin series is that x naught is equal to 0, and we know a formula for the coefficients, right? So this is equal to the sum. N goes from 0 to infinity of the nth derivative of our function defined at 0, or applied at 0, over n factorial times x to the n. This right here is the formula for the Maclaurin series. This, you just need to know this. You need to memorize this. We worked out a formal, proof, maybe might be a strong word, but we worked out some reasoning, right, to show that these are the correct coefficients. So what we have to do is we have to determine these coefficients, and we have to try to notice a pattern and find a formula for the nth coefficient. And the best way to do that, in my opinion, is to make a table. Okay, so we're going to make a table. We're going to take some derivatives of our function. And hopefully 6 of them will be enough here. If we need more, we'll take more. Like I said, we're going to take the derivatives of the function f of x. And then once we know the derivative, we're going to plug in x equals 0, and we're going to write down our coefficients here, fill in this table, fn at 0 over n factorial. You always have to divide by the n factorial to find this coefficient. So we want to do this for the function cosine of x. So I'm going to just write the cosine over here. We're going to fill in our series. Cosine of x is the function, right? So the 0th derivative is just the function itself. When I do these problems, I like to fill out at least the first few derivatives first, and then go over and fill in the coefficients. You can do this any way you want, as long as you make sure that you take care of everything, right? But I'm going to go the way that I'm used to, which is take a bunch of derivatives. So the derivative of cosine is minus sine of x. Derivative of minus sine is minus cosine of x. And then we get into this cyclical relationship, right, where the next derivative is positive sine of x, and then one more derivative, we get back to cosine of x, right? So the fourth derivative of cosine is just cosine itself, and in between here we've got a negative cosine, there's a couple signs, and then it just repeats, right? So negative sine of x, negative cosine of x, etc. And just by this process, we can't really write down a formula down here for the nth derivative that's super 9. We could figure it out. We could definitely write a piecewise formula for that. But what we do know is that this is kind of cycling through, right, in groups of 4. So there's a cycle of 4 derivatives, and then it repeats, right? And that's very important, because what we can do now is we can write down our formula here for the nth derivative applied at x equals 0. So cosine of 0 we know is 1. Sine of 0 is 0, right? So I've already forgotten. We need to divide through by n factorial. So this first term is 1 over 0 factorial. The next term is going to be sine of 0, which is 0 over 1 factorial. And then the n equals 2 term, it might be helpful to draw some lines here. The n equals 2 term is going to be negative cosine of 0, so negative 1 over 2 factorial. And then this process is going to continue where we have a 1, a 0, a negative 1, a 0, right? Sine of 0 is 0 again. And then we continue this on, and at every step we increase the denominator, the factorial in the denominator, based on whatever step we're at. So the next one here is 1 over 4 factorial, and then 0 over 5 factorial, etc. And so we, again, get to a point where we need to find a formula here, and it's not so clear. So this is a little jumbled up. Let's write out the first few terms here. Remember, 0 factorial is just 1. So this is going to be equal to 1 times x to the 0. So that's just 1. Plus 0 times x. There's no x. That's 0, right? The next one's going to be minus 1 over 2 factorial, x squared. And then plus 0x cubed plus 1 over 4 factorial, x to the 4th. And then this continues on, right? So there's 0, x to the 5th. And then the next one's going to be minus 1 over 6 factorial, x to the 6th. And it's going to continue like this. And the pattern itself continues, which is this, right? If you look at this, you see that all of the terms that have an odd power, an odd n, all of these are zeroed out, right? Their coefficients are 0. Only the ones with an even coefficient remain, and then between those, look what happens. We start with a positive 1, and then we get a negative. Positive 1 over 4 factorial, negative 1 over 6 factorial. And so this is an alternating series, right? This is an alternating series. And we can guess, by the way, that the coefficient is, number 1, it's alternating, and number 2, we look at the power at every step, the power on the x, and we compare it with the denominator, and the factorial matches what's up above, right? And so we need to find a way to represent just the even terms here. We need to make them alternating, and then we just divide through by the factorial of the power. So this is going to be then equal to the sum. N goes from 0 to infinity. We need only the even terms. So how are we going to represent just the even terms? Well, no matter what n is, 2 times n is always even, right? So the power on our x is going to be 2n. So x to the power 2n. That's going to pick out just the even terms. Then, in the denominator, we already know this, right? We talked about this. The factorial is the same as the power. So what goes in the denominator? It's going to have to be 2n quantity factorial. So notice I put that in parentheses, 2n factorial. Now, the last step is to make sure that we get this alternating taken care of. So these start with plus, then go minus, plus, minus. And so, in terms of our alternating series, the power has to be such that when n is even, right, when the step is even, so we have the, when it's odd, right? No, when it's even. So we have 0, we start at 0, right? So 0, then 1, then 2, then 3, etc. And so we have negative 1 to the n here. All right. Now, if that's not super clear, then what do? You work out the first few terms. When n is 0, negative 1 to the 0 is positive 1, right? So 1 over 0 factorial, x to the 0. Good, right? The next one is going to be 1 to the 1, negative 1 to the 1. So it's negative 1 over 2 factorial, x to the 2. And then it's going to be plus negative 1 squared over 4 factorial, x to the 4, etc. And at this point, you can check that the series is correct. So this is the Maclaurin series for cosine of x. And let me just write it down and we'll stop here. Cosine of x is equal to the sum, n goes from 0 to infinity, of negative 1 to the n over 2n factorial times x to the 2n. So there's the Maclaurin series for cosine of x.